So now we're going to talk about how to determine potential energy values and hopefully even do like a problem. All right. So one of the important things that we need to remember about assigning actual values to potential energy is that we can only discuss the difference in potential energy between two configurations. Because remember, we said that the potential energy was associated with a system of objects that had a particular arrangement. So at the end of the last one where we were talking about a block being a certain height above the table. When we talk about the potential energy of the block, we're actually talking about the potential energy of the Earth block system. And we can't even talk about the potential energy of the block at a particular position. We can just talk about the difference in the potential energy between when the block was sitting on the table and when the block was up in the air above the table. So that's a really important thing to remember. Now, so far, the only equation that we have with potential energy in it is that the change in potential energy is equal to the negative of the work. But there's actually a lot of information in there that we can use. So, what's the general formula for work? That F dot D only works for a constant force. What if I don't know if it's a constant force or not? Or, yeah, what if I want to, what? Yeah, but it's really not that simple anymore, and that's really not going to help me come up with a formula for the potential energy. Nope. Nope. Well, we can't use F dot D. Well, we can't use F. Okay, back up. I don't want to use F dot D because I don't know if that only works if F is a constant force. I want to get a more general formula. Making it equal to delta K, that means I have to figure out what delta K is, and I might not know what delta K is. Or there may be no delta K. If I'm talking about moving a block from the surface of the table to up above the table, there may not be a change in kinetic energy, but there's still going to be a change in potential energy. So Zoe, what were you going to say that work was equal to? The area under the curve, and the calculus way of talking about that is the integral. So if my force acts between some points, x initial and x final, then the work is going to be the integral from x initial to x final of f of x dx. Which means if I combine these two equations, then what I have is that change in potential energy is going to be the negative of the integral from x initial to x final of f of x dx. Okay? So let's take some conservative forces that we know about, use this equation, and see if we can figure out how to express the change in potential energy that's caused by that force interacting between a particle-like object and the rest of the system. So what's everybody's favorite conservative force? The gravitational force. Okay. So we know that that magnitude of Fg is going to be mg because we've done it a million times. But remember that if I'm going to figure out what the potential energy values are, it needs to be between two different configurations, two different arrangements of the object and the Earth. So my object is going to start here at y initial and end up here at y final. And the force that is transferring that energy is going to be the gravitational force. I'm going to let up be positive, although it doesn't really matter. And then let's calculate delta U. So my formula was delta U was the negative of the integral. In this case, it's going to be y initial to y final of f of y dy. And my f of y is just going to be mg. Okay? But which way does fg point? Down. So fg is going to be in the negative direction. So really my delta U is going to be the negative of the integral from y initial to y final of negative mg dy. All right. So these two negative signs are going to cancel each other out, right? So I'm just going to have my integral from y initial to y final of mg dy. I can pull out the mg because it's a constant. And although we haven't talked about it before, integration is really the inverse operator of differentiation. So taking the integral is the inverse operator of taking the derivative. That's why I made such a big deal about inverse operators at the beginning of the year, that they undo each other. Okay? So what I want to do is take the antiderivative of the thing that's under the integral sign. And remember that this symbol and this symbol are really bookends. And whatever is in between them is the thing you're taking the antiderivative of. So what's between them is really the number 1. What's the antiderivative of 1 going to be? But in this case, it won't be x, it'll be y. Okay, so I still have my mg hanging out front. When I do my integral, I get my y, but because this is what we call a definite integral, I need to evaluate it between my limits of y initial and y final. Now, what's the other way we talk about an integral? What's the graphical interpretation of an integral? The area under the curve. So if I go over here for a minute and I make a little graph of y and f of y, what am I going to plot on here? Not just a straight line, but a horizontal line down here at negative mg. So if I want to find the integral from y initial to y final, I'm going to be taking the area of that rectangle. Which is going to be the height of the rectangle here, which is negative mg, times the width of the rectangle, which is y final minus y initial. And it is below the x-axis, so it is going to give me a negative area. But if you recall up here, I also had a negative sign in front, and those are all canceling out. Okay? You with me? All right, 2 different ways to go at it. By February, taking this integral is you could do it in your sleep, okay? Because we'll feel that much more comfortable with them. So what I'm really going to get here for the change in work is going to be mg times y final minus y initial, because that's what I do with the limits. I take the top value and substitute it in, minus the bottom value, which I've substituted in. And sometimes I write this as mg delta y. Okay? Now sometimes what we do is if I've got an object and I'm going to measure, it starts here, it ends up here. Sometimes what I do is I let yi be equal to 0 and ui be equal to 0 there. And we'll finish that up later. Okay? I will have a weekend.